All right, so in previous sessions we had kind of a curtain wall panel that had a varying surface, so we'll definitely do that one today. And then we'll also build out a kind of double skin facade as well. And each one of these panels is going to inject itself into a curtain wall panel. So just to start in the project level, I'm just going to draw in a standard curtain wall and plan. Make it as big as you want. Go to 3D. Right, just no divisions yet, nothing of the such, just a single panel. So we'll leave that as is. So we have a project ready to go and load that in. And then I'm going to make a new family. So when I'm making my own curtain panel, such as just a glazing system or whatever it may be, and I'll give you guys some examples that you can use on your projects, as well as you'll have the content from today too. So it's always going to be a new family that makes the panelization. Come into my family templates, and it's not going to be a generic model. In the case of the parametric louver, yes, it will be a generic model, so we'll show you kind of a hybrid workflow. But to start, we did last week the curtain wall pattern base. That's for the massing divisions only. The next one is the actual curtain wall panel itself. So this is more of a rigid system to build within. So I'm going to start there and go ahead and open that. So initially, when I open up this family, I see an exterior. So anything that's going to be on the exterior skin of my building is going to be on this side. Again, I'm looking in floor plan. If I go to my project browser and look in elevation, right, this is the division of curtain panel, okay? So these lines are defining my divisions. So to start, if I go ahead and just make a simple extrusion, and I'm going to lock it to those reference planes. And if I load that into my project, go to 3D, I select my panel. If I tap through to grab only my panel, I can now switch it to my new family 1 panel. So that gives me my extrusion. Now, if I start to divide this surface out, right, each one of those panels now, it's the same panel that's being loaded by default, but the difference being is that each one of these now, those 4 division lines that were in my family are corresponding to grid lines, okay? Does that make sense to everybody? So what I'll do, whenever I open a new family like this, it's labeled as top. I'm going to change its name to top grid line. So I know that those correspond specifically with my curtain grid line. Okay, so that gives me my panels. Now, if I wanted to, so I'm going to delete off that extrusion. I'm going to start building out something that has mullions within it, as well as the glass panel. So I'm customizing my surface. I'm building the mullions into the family. I'm not relying on Revit to generate those mullions. So I can easily go ahead and do a reference plane, and then another reference plane, one at the bottom, one at the top, one at the middle for my spandrel glass. Okay. And then what I can do is DI for dimension, and I'm going to put constraints onto each one of those. So that'll give me an equal mullion spacing. Now, it's not perfect. For the left and right sides, I would want to divide those in half, right? Because they're going to lay next to each other. But for demonstration purposes, I think this is fine. Select my dimension string. Go ahead and add parameter. Call it mullion width. And then I'll add that to each one of my angles here, or dimensions, excuse me. Constrain the sketch. So that one, don't need it on one side. There we go. Right, and then I would want a height for my spandrel glass. So I can add in my height of spandrel. And And that's basically it. Now in floor plan, I see now, when I select my line, I should be able to look at it and say, okay, there is my grid line. So that's why I name my reference planes all the time. I don't need to constrain it in the floor plan. It's already constrained in another view. But some other things I need to think about, right? So whenever we do, I'm gonna have to draw this out for you guys. So whenever we do curtain systems on high rises or of such, whoops daisies. Fun with markers. Alright, so there's two different types of ways to generically hang glass on top of a high rise. This is my slab condition here. And people over here, I'll try and move out of the way somewhat. Right, slab condition. Right, I can either put my glass here, draw in glass. Either have my glass run in between the slabs, or I can have it hang on the slabs. And each one is a valid choice, right? In case A, case B, A, B. In case A, right, I'm handling any thermal breaks, right? I have an attachment on the edge of my slab, and I'm connecting it into some type of attachment here to hold that glass in place. And attachment B, I'm using gravity loads on that slab edge to continue it. Now in case B, right, case A is easy to do, right? This is my span profile. Simple. In case B, what I need to do is in my family, right, I need to handle, in this case, well, we'll do case B. In case B, I need a slab edge cover, right? So if my slab is coming in this way, I need to cover that slab in some fashion, right? So that way I handle any thermal break. Who doesn't know what thermal break is? You guys are learning. Right? And that's just for airflow. So I need to build that into my family. So within plan, right? Right now in plan we have these two reference planes. Mullion. I'll need to build in a line for one, my slab edge cover, and then I'll build off each one of those. So I'll be handling offsets within this, right, to move it inside of that slab or outside of that slab. Makes sense? That same idea of offsetting is going to be for case A too. So we'll make it try and do both. Any questions on that? All right, so building off of that knowledge, I won't build anything on top of this front. This front level line is like the slab edge, right? That's where my line ends. So I'm going to build a new reference plane to mimic that line. And then I'm going to do another one for the mullion depth. And then I'm going to do another 2 for the glass thickness. And then I'm going to do another 2 in front of my front line for slab edge cover, right? That's it. And then I'm going to dimension those accordingly. So this one is slab edge cover. And I can name my reference plane. So I always want to name them. Slab edge cover for those. And I can't do it for both, so I got to do edge cover front. So that way when I select it, I don't get confused. Because you can see right now, it's going to make me severely confused. Edge cover back. This is my front reference line. This is mullion front. This is mullion back. And then glass 1, glass 2. Glass 1, glass 2. So then what I can do is start building in my logic. So this one would be glass thickness. This one's going to be mullion depth. Then I'm going to inset my glass. Okay? And then I'm going to have an offset for both slab edge and curtain glass. Okay? And then within this one, so this I know is slab edge cover. So I'm going to add a parameter and call it slab edge depth. And then this one's going to be mullion depth. This one's going to be glass thickness. This one's going to be offset, slab edge offset. This one's going to be curtain panel offset. Fun with families. So we'll call it panel offset. A loof set, and then glass inset. There's a lot that goes into making just a simple panel, but that should cover us for everything we need. Right now in the front, now that I've gone to plan, I'm going to go back to my exterior elevation. So I have, right, I don't see any of the ones I want. Now the edge condition, right, this is where my floor is, right? So anything below my reference level is where I want to model my slab edge. So I can model below that as well. There, and then DI for the top. So put one at the top edge of this. Add parameter slab edge thickness. I think I already got one of those. Nope, good. And I'll do the same at the bottom because typically you're going to have an even depth for your floor. So I'll add the same one there, slab edge thickness. Okay, so you can kind of see how I'm wireframing this out. You could also put, if you'd have an operable window probably here too, you can put that in if you'd like. Right, so now once I have that, I can start building in geometry. So the first thing I'll do is get my mullions into place. So I'm going to create, at this point everything's just simple extrusions. Create my extrusion. Lock it into place on all four sides. And then I'm going to, and sometimes this breaks, sometimes it doesn't. I haven't figured out why. Some days this works, some days it doesn't. But I'm going to attempt to make the whole entire thing in one shot because I'm lazy and I don't mind admitting it. Okay? And then I'll check. There we go. And now once I have that, I want to flex it and make sure that everything stays stuck. So that is handling my mullion widths. So I'll make sure that that is 4 inches. Flex it one way. Cool. Flex it the other way. 1 inch. Rock and roll. All right, so then the next one is the infill. So I always turn on it. By default, it's on wireframe. I'm going to turn it to shaded. Once I'm in the shaded view, I'll start building out the glass. So I do another extrusion for glass on the inside. So now you'll see, because I already have geometry, it's going to try snapping to geometry. And we never want to lock geometry to other geometry. So I'm going to cancel out of that. And so I don't lock anything accidentally to these, I'm going to go ahead and hide that element. Then I'll put in my glass. And then lock that to my reference planes. Check. And then I'll unhide everything. And then I'll double check my set. So a quick way to start kind of toggling this flexing, because I have a lot of parameters within this family itself. So what I'll do is I'll set up 2 new types, call it test case A and then test case B. right? So I can just switch some values so I can quickly toggle between the two. So I don't have to start typing things in. I type them in once and I just toggle between the types. Does that make sense to everybody? Yes. So in my case right now, I'm just checking mullion widths and glasses. All right, so that's case 1. And I removed my properties there. Properties comes back. Then I'll check test case A. Make sure that that works. Rock and roll. Okay, so that's that. Last 2 pieces, slab edge covers. So the slab edge covers, you may have varying floor depths, right? Or floor edges. In my case, I'm just going to assume that this is like the generic panel. It's going to be a rectangular high-rise. So I'm going to build both of those a similar fashion to the mullions, more so just to save time in the tutorial here. So I'll create an extrusion. And I'm already ignoring my rule of thumb. So I know that I'm operating on reference planes that have geometry already snapped to them. So I want to hide the elements that belong to those. And then I'm going to come in and create my extrusion. Draw a pretty little tree. Check, 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 and check. And I'll do the same thing at the bottom. Okay. And then what I'll do is reset my temporary isolate hide. And then on each one of these, so now this is an element that of its own. I want to go find its parameter in test case A. I'm going to change single value 1 time, and then I can do my toggle. So it'll also toggle my mullion width and my slab edge thickness here. So I'll take that down to 6 inches for this case. Apply. And OK. So that works. For that case, then I'll flip to test case B and apply, and it works. So nothing's broke yet. So then once I have that, I need to come into my reference floor plan, turn on shaded view, right? And now I see everything is gray, which for me kind of sucks because I have no distinguishing marks between what is what. So at this point, I'll go to a 3D view, and I'm going to take my pieces and I'm going to assign material parameters to them at this point so I can use that as a distinguishing element as well as serve as any graphical purposes within the project when I get to that point. So I'll select each object 1, slab edge cover, which is going beyond my mullions. I'm going to ignore that for now. Okay. You want to make sure you don't do that. And I'll put a material parameter on it called slab edge cover. And I'll put a material parameter on my mullions. And I'll do the glass. Now one thing we're going to run into, and we'll get into that once we see like the basics working. We'll start adding visibility onto it. But I'm going to need to eventually separate off those slab edge covers. Alright, so we'll call this glass. Okay. So that gives me that. And then what I'll do is also go back to here. So now I have my 3 parameters for my materials. Go ahead and just use the default generics just as long as they're different colors so you can kind of see what's going on in the family. So 1 default wall is fine for my slab edge cover. I'm going to give it a graphical representation of not yellow. Apply and OK. And then, whoops, come back to this. Mullion material will then be poche. We'll call that blue, which is fine. And then glass is, well, glass. Apply. And then on test case A, right, I know the materials are going to work, so I don't need to set up 2 conditions on that one. There we go. Go Spider-Man. All right. Okay, so you'll see now when I'm looking down at plan, I knew that everything that was blue was mullion. So right now I'm actually looking at a cut through my mullion. And that's my glass. So it's not necessarily cutting the way it's supposed to be cutting, and or this is glass on top of mullion, which are both materials are blue when they get cut. So I know from the way my geometry is working that that is in fact my glass. So I can take my grip handle, drag my grip handle in, and make sure I snap that to the corresponding glass thickness reference planes and lock it. Then I'm going to take my mullion set, and you'll see when I select it now I see some purple, so that's telling me that something is below this item, and there's a way we'll have to go to get the ceiling as well. I'm going to take this and pull that into my mullion depth and lock it. Now it's already locked on the side, so I am only controlling the depth at this point. Okay, and then my slab edge, I'll make sure that my slab edge corresponds with where my slab edge lies in plan. Okay. Now I need to, there's no easy way to look, go France. There's no easy way to look in the you know, my cut plane's at 4 feet, right? There's no way to toggle that cut plane in the family. So the only way to look above the cut is to go to the ceiling plan view, right? And then I see, because I made my slab edge covers all in the same family, it handled both conditions for me. In the event that it didn't handle both conditions, which we're going to see later, I would need to go to 3D and use faces to align faces. That's the time where you would actually lock geometry to geometry, right? So the last part of this kind of basic idea of a family is to come into my family types, and I'm going to change every value now. And I can just do it on test case B. It's fine. Spandrel height, we're going to give it at 1 foot. Slab edge offset, we're going to give it at 1 foot. Slab edge depth, 1 foot. Panel offset, 1 foot. Mullion width is fine at 4 inches. We already changed that. Mullion depth, not 1 foot. 5 inches. And glass thickness, 1 inch. And glass inset, 1/2 of an inch. And then hopefully, if I click apply, nothing breaks. And then nothing broke. For you, it's probably going to break a few times. For me, this is probably the 15th time I've done this family, so it doesn't break anymore. I've done it so many times, I just know the process to take. So that's the correct process to do something like this. It may be different for what type of condition you're doing, so you'll need to just kind of play around with it and figure it out. So once I have that, I can load it into my project. I'll overwrite that existing version, and then when I go to my 3D view, you'll see that I have my panels. Now, in this case, right, I have slab edge running over, and I have some overlapping, right? So that's a problem. So how we handle that condition is I need to make a panel top, a panel bottom, a panel left, and a panel right, right? Because then in certain ones, I'm going to turn off, right? So panel top would only have the slab edge at the top. Panel middle would have none of the slab edges visible, or just tops, or just bottoms, and then the one at the bottom would have just the bottom condition. So I need to go back into my family and then edit that condition, setting up this super panel. Right? So then to embed that logic, right, I need to first split off these two slab edge covers. So I'm going to come in, and I'm going to edit the profile 1, and I'm just going to delete off those lines and check. And then this one, instead of making, I'm going to make a new extrusion with it. And then while I'm here, I'm going to bring this up above. So AL for align. Oops, wrong one. Move that constraint. So that looks more correct. All right, and then this one, I'm going to come in and put my new extrusion piece into that. Check for that one. Hey, oops. Probably could have just aligned it, but it's less clicks on the mouse and keyboard just to undo it. Check. There. Then I'll take that one, assign the material to it. Slab edge cover. Right, and then I need to go to 3D. So what I'll do is I want one is already driven, right? The other one I want to react to the because it's in, we would imagine I did it reverse, right? I did the one in ceiling. So then I would just take and align the faces of my edge cover. So one goes to one, the other one goes to the other one, right? And then I would toggle my test case and make sure that that is still a working family, which it is, which is good. And then I'm going to put a visibility parameter, 1 and 2. So 1 gets a visibility called slab edge top. And then I'll call another one slab edge bottom. Click OK. Right, and then I can do one that has 0, right? So we'll make now new types. So now that my types are set up, I have all my conditions that I want within my panel family. I'm going to remove, right? I'm going to remove these test cases or rename those test cases to be panel top, new panel bottom, new panel no covers, right? So on panel no covers, none of those slab edge covers are visible, right? And they should go gray in the family. Test B, delete test B off. Okay, panel bottom would have only slab edge bottom visible. Panel top would have only panel top visible. Right, and then I'll load that back into my project. Overwrite the existing version and parameters. Voila. So now if I go to 3D, it's nice and cleaned up. So then these bottom panels, if I tab through, right, each one of those are designated as panel top. If I type UP for unpin, should unpin them if they are pinned, and I'm going to change them to now panel bottom. Okay? And then I'd probably need one that has both visible for that condition, right? Make sense? So I would need a fourth type. Easy way to generate a fourth type would go to my families inside the project, right? So we're embedding logic that the user can use. It's curtain panel. I have my family 1, and I'm going to create a new type. Call it in project family. Edit my types, so then within that operates the same as a door family, and I say that both are visible, and then those panel conditions become where both are visible. And flop that out in project family. So there we go, cleans it up, right? I would match parameters, yada yada yada. Does that make sense to everybody? Pretty quick. It's at 40 minutes, something like that, half hour to build that one out. All right, so the next thing I want to do is kind of begin talking about, and we've talked about nesting parameters, but we really haven't talked about some other embedded logic, and this is kind of building us into structure, and that's why I'm going back to kind of cover this, because I want, when we get into structure, for it really to make sense on the power of it, because parametric arrays, that's what structure is. It's just a unit that's multiplied in most cases, okay? So to build out the parametric array, I need to start with, there's a hierarchy to this. So let me come over to my, I take my markers with me. So the hierarchy is going to go for the parametric array. We know we have our panel condition here, right? Slab edge covers, there, right? So that's a family, right? That's going to host all other elements. Now to make the louver system, I'm going to start at a generic model, and I'm going to build within that generic model one single louver extrusion. That louver extrusion is going to be based on a sweep condition, not like the extrusion, but we're going to sweep a path, right? And by sweeping the path, I'm allowed to load in a profile that has conditions. So this profile is a profile family. Okay? And then from that profile family, I'm going to path in parameters to my generic model. And that's where all this will live. And then this entire subset is then going to come in to another generic model family, louver array. And then that louver array is going to get all parameters from the louver. Parameters get passed into this one. And then within this family, I control the multitude, right, of how many I want. Then from that, we're going to take this over and embed a logic that reads whatever my grid line becomes. It's going to fluctuate my array cells based on whatever that distance is, okay? All right, so let's do it. All right, first thing I know I'm going to need, the core cell of that is going to be a profile family. So I'll start with a profile family. It's just going to be a 2D element. And it's going to be a simple box. Draw some lines. And actually, I'll probably embed some logic to it, so I'm going to give it a length and a width. And so at this point, it's like, you have to be aware of how I'm going to nest this. So I could load it on center point, or if I wanted to embed rotation. So it's always tricky to get rotation. So I'm going to try it again this one. I'll probably fail on it, so I haven't found the best way to make the rotating louver. So let's give it a shot here. See if we can do it. All right, so I'm going to say that my profile family is going to rotate too. So do I want it to rotate based on center point or what? Yeah, I think we'll do center point. So I'll do RP for reference plane, reference plane, reference plane, reference plane. And then I'm going to put an equality constraint onto that element. And this is going to be tricky. It's probably not going to work. Yeah, it's not going to work this way. And we'll try it, see what happens. And then I'm going to create my line component over that. Lock it in 4 places. And I'm going to do a DI for distance command. I'm going to add a parameter for width, or thickness, we'll call it. At this point, naming is not entirely important because we're going to path these in and rename them anyway. And we'll add a new parameter called louver width. Right, and I can adjust that if I want. The reason why rotation at this point is not going to work is because of the embedded logic, right? So I would need to, I'd have to build a third tier of data, right? So I'd have to do a profile family into another profile family to get it to rotate, and then load that one in. So let's give it a shot. Why not? Hell with it. So I'm going to do a new family, and then profile. So we'll immediately begin learning about nesting from this then. So then within this, I'm going to save this one out. So that way my naming is consistent. So I'm going to call this louver profile 01. And then I'm going to load that in to my new family, family 3. And then I'm going to place that. So that should be, so that's a detail component. Go to my project browser, families, profiles. louver profile 1. I'm going to drag that in. So I can't load a profile into a profile. So we'd have to make that a detail that then gets rotated. All right, so that answers my question. The one I provide, I'm going to figure it out, and then I'll upload the one that actually has rotation, just so I don't look like a dummy up here. Okay, so then once I have that, I'm going to load in the third tier, or the actual generic model family that's going to make the sweep for my mullion, or my louver, excuse me. Call this a generic model, and we can categorize it later. So again, how am I loading this in? Right now I'm looking in plan. So if I'm going to be loading this in plan, then I'm going to draw in plan. If I'm going to load this in elevation, then I'm going to draw in elevation. So in this case, I'm going to load it into my front panel because it's an elevational element, right? I'm going to control my array in elevation. When I load in my sweeps and everything else, it's going to be loaded into here. So I'm going to do RP for reference plane. And I'm going to load it based on center of that panel family. So I'm going to kind of mimic what's going on in this family so I can start embedding logic to that one. Right? And then I'm going to need another reference plane to control height of that louver. So then we'll do an equality constraint on this one, DI for dimension. DI for dimension on this one. So this one's going to get a louver width. This one's going to get louver thickness. And then I'm going to go to my reference level and go louver depth. So again, am I loading on front or back? In this case, I'm going to give precedent to the front of my system. Right? This is my center, front, back, so this would be my front. And I could have got it wrong. I could always flip it. We'll put a flip control in it so we can toggle front or back. DI for dimension, louver depth for the parameter. Okay. All right, so then I can load in my profile and start drawing my family. So actually what I'll do is also draw in a reference plane, put an equality constraint on this, and this is because my sweep is handled based on center. So what I want to do is draw in now a reference line to sweep off of. And I'm going to align that line to my reference plane. And I'm going to check and make sure that it flexes. So that gives me my line. Okay? Within that line, I can use that as a sweep path now. Okay? So when I look at this, it's going to get funny because depending on where this is drawn, it's going to load in my profile. My profile was drawn based on center, so this is going to become center. So I'm going to have to host my reference planes to my actual geometry, which is kind of funny. Okay? So I'll go to front, right? So there's front. So you'll see my line is loaded down here, right? So I need to then remove that. And make sure that that is actually centered on every element. Crap. Funky. There we go. That was louver thickness. Okay. Cool. Then I'll need to go to my left-hand side and make sure that my line is in the center of that. So which it is. So we're good. Alrighty, so then I'm going to load in that profile family into my new generic model family. I'm going to path the parameters of louver width and thickness into the new family so that the new family controls everything inside this family. So I never have to open this up once I have it embedded. There we go. Doesn't do anything. So the next thing is to instantiate the sweep. So So I go to sweep, and I'm going to use my pick path tool to pick my reference line that I made. Okay, so that selects that reference line that's constrained to my reference planes. And then if I go to 3D, I'll see now when I load my profile in, it's going to load at this center point based on whatever logic I give it. How's it going? No problem. You're on the video now. Welcome to Kreger Video. Whoop-de-doo. All right. Always throws me off. All right, so here we go. So then I'm going to load in my check mark. I got my path. The next thing is I've already loaded in my profile. So in the event that you didn't load a profile, I can load my profile here. I can draw in my own profile and give it logic. Since we did this kind of the right way, you should be doing it family to family to family. I'm going to select my louver profile 01. So there's my louver profile 01. Check. Done. The last part is to take the embedded logic of this family and host it to my new family parameters within this generic model family. So I'm going to right click on that family's elements, which is the profile elements, and I'm going to go to edit. Well, that edits it, excuse me. I'm going to path its type parameters, so type properties. Louver thickness and louver width is going to go get louver width is equal to now louver width inside this family. And you'll see it changes it now to read the value of whatever's inside this family. So I'll do the same thing with thickness. Click OK. Now it changes it. So why does it change it? And that's because louver depth hasn't been associated. So my louver width is actually my louver depth in this case. So when you get an accurate case, which I do quite often, I'm just going to change louver or thickness to be depth. Nope. So maybe I had it right. Fun, fun, fun. Louver thickness. And then louver width is now louver depth. So naming at this point really does... Oh, what did I do? There we go. So that changed it. It's just my graphics card updating. So now in 3D, should have my family. Now my three controls, I want to make sure that my three controls, the only thing that I'm really actually controlling in this family that hasn't been already created in the other family is the width, right? So right now louver depth is louver depth. I can take that down to 6 inches. Do my louver width, or my louver thickness to be 1 inch, and louver width to be 8 feet. And apply, and there we go. Louver blade, okay? So now we're going to take the louver blade, that same nesting logic, and put it into a parametric array. So I can control the how many, right? I'm going to embed a logic. It's going to calculate something off of that. Okay? So I'm going to go and do another family. So I'm going to do a new, I'm going to save this one out so I have a name to it. Save as family. I called louver profile. This one's going to be louver blade. And then louver blade. All right, so then I'm going to do a new family, generic model, because at this point I'm going to use whatever trumping value is ahead of it to then determine what that entire profile is actually, or that family is scheduled as. So I'll do a new family. Family. Generic model. And then again, am I loading in an elevation? Is it an elevational characteristic or is it a planar characteristic? Plan form characteristic. So I'll go to my front view. All I need to control at this point, now I'll need to think, right? Because I'm embedding logic into a new family. So if I went to do an array with this family, right, and I just did the array function, I would still have to open up the last family and control parameters. So even though we're not controlling anything in this family, I still want to path those parameters so I can grab them in the next hierarchy of family, right? So the first thing I'll do is load in my blade. All right, and I'm looking in plan, so I'm going to go to the front of this. And then I'm going to go to my front view as well. and I'm going to align. Okay, so we're going to need to align, tab, align to the bottom, right? And then I'm going to do so I want to keep it loaded on center, right? So I take back what I said before. We are going to have to embed a little bit of logic into this. So I'm going to do RP for reference plane, DI for dimension. And I'm going to break it for you and show you why we need to do this. So I won't do it yet, right? So I'll just do the array. I'm going to drag this out so everybody can see. Right? So to do the array, I need a top function as well. So where does this thing end? And then a simple way to do it is to do AR for array. I'm going to go based on my center. Now, actually, I got to back up here. AR for array, select, spacebar. Now, here I am, and I want to, there's a few things that I need to make sure that I check on this. Excuse me. One is going to be, I'm not going to move to the second. Moving to second is basically going to say that I'm putting in a spacing value. How many do I want based on this spacing? I want them to flex within a dimensional constraint of how much space do I have to fit how many louvers. So I'm going to move it to my last. And then I want to always make sure that I'm on group and associate as well. And then I'm going to take the top condition and move that up to that reference line. Give it like 4 for now so we have some visual cue. And now when I move my top reference line, right, it doesn't stay stuck. So I need to then AL for align and align that to the top. Now what I can do is then move this, and it's going to grow my value based on some condition that I set up. So the next thing is to set up a condition, right? What's going to happen is if I need to lock the left and the right, because what's going to happen is if I go in and change the properties of this louver, so to change the properties of a grouped object, I'm going to edit it, not ungroup it, because if I ungroup it, I lose the ability to make an array with it. And then I select my object, and I'm going to right-click and edit type, or go to type properties within that element itself. So if I change my width to be something like 12 feet, right, we got lucky because it was on a center point. There are cases where, depending on how you do this, it's going to stagger my array system. So let's just say finish for that, and I'm going to do AL for align, and say that I'm going to align my left condition, right? It'll stagger it like that, okay? So I still want to have control in this family of that width and still have it aligned. So I need to make sure that I'm always aligning top left condition and top right condition. So left, or top and bottom conditions. There. Good. Then I need to start controlling those same parameters that I had in the last family. So I need to add those in. Add parameter, louver width. Add parameter, louver height. Louver thickness. Add parameter, louver depth. Add parameter, number of louvers. Louvers. And that one should have been a number or an integer value. So I'm going to add it again. Make sure I change it to integer. Number of louvers. Man, I keep spelling that wrong. And let's see, number of louvers, and then spacing. And then I need an overall height. Okay. And then I want to make sure I have values for each one of these, because it'll break if I don't put in values. So spacing, we'll give it 6 inches. Overall height is equal to 8 feet. Louver width is going to be 8 feet. Louver thickness is going to be 1 inch. Louver depth is going to be 6 inches. Number of louvers, we'll just do 12 for now and click apply. Okay, so now I need to go into my family, which again, it's an arrayed group, so I need to leave it as a group. edit one of those initial conditions, edit its type properties, and get my family to start driving those conditions. So louver width is going to be equal to louver width in this case. Now, because I constrained my element prior to pathing my variables, I have a problem. It's breaking my system. So I'm going to remove those constraints and let it take over. And then louver depth is louver depth. Click apply and click OK. And then finish. Right, so you see I have some funny things kind of going on. So I'm going to realign those now to here. Well, before I do that, I'm going to actually then take this one and call this louver width. And then this one needs to get louver heights, or overall height. And I believe that covers almost everything. The last part is to then put, well, we'll get it aligned, get it flexing so it doesn't break, and then we'll do the last arrayed system. So lock it and lock it. Okay, so that gives me that. Make sure that at least my dimensional characteristics change. Now I'm going to set up my test conditions. Because I hate having to type multiple times because I'm a horrible typer. Spacing is now 1 foot for test B. Overall height is going to be 10 foot for this one. Louver width is going to be 10 foot. Tab. Louver thickness will go to 2 inches. Louver depth will go to 1 foot. Number of louvers will do 24. Apply. Okay. So now I should be able to push and pull that. Looks good. If I move this, moves everything out, looks good. Now we have a parametric array of louvers that are working. The last thing is to now set up the logic that takes the overall height, divides out how many numbers I want, and then controls my spacing. Or vice versa. What do I want? You know, we can reverse that logic. So we'll go ahead and take my louver. If I hover over it, it's kind of hard. I still have a problem. I got to kind of zoom in and select. So there, I select my numbered arrayed system. I can add a parameter called number of louvers to that one. Bam diggity. Last part. Turn on shaded view so I can see it. Now I want to set up a logic so that way as I change the height, right, it adds more louvers to my system. So to do that, then I'm going to, and spacing might not need to be there, so it's going to be, yeah, so I'll say, what do I want my spacing to be on my louvers? I'm going to take my overall height divided by my spacing, and that's going to give me how many louvers I have. So then number of louvers is equal to overall height divided by spacing. And apply. And you'll see it changes it. Okay? Test A, 16. There we go. So now as I grow my value, it's going to fluctuate somewhat because of the remainder value within it, and we can control that with a rounding function. But as I grow this, it's going to build more and more and kind of contain it within a set kind of boundary of around 1/2 inch, right? So we'll be between 5.5 inches and 6.5 inches for our spacings, right? Before we add a new louver. So that's our parametric louver system. Now we need to add that so it actually does something inside a curtain panel family where we actually want this thing to be, right? So I'm going to save this out as parametric louver. Louver system. So we have louver profile, louver blade, and then louver system. And I'm going to load that one in to my family 1. So this is where it gets fun. So now I'm going to place that right on the center point there. Now I need to set up a condition. If I try and constrain my width, right, I want my width to basically grow along the whole edges of this thing. So I can go through and I can nest and I can path all those parameters again. I don't think you guys need to sit here and watch me type in a bunch of paths. So we'll just assume that we did this for this family. There's two little conditions that I need to show you on how to get them to work. So if I go to the front value of exterior system, right, I need to get I know that this line, right, or actually this grid line, if I look at its properties, is my top grid line. So I need my louver array system to read values that are reporting back from it, right? So it's basically called a reporting value. So I'm going to say that, and I might have to go back into the other families with this. So I'm going to take and put on a reporting parameter. So I need to do DI for dimension. Now this is not controlling, it's reading. So there's like the read-write function. This one's reading. Everything else we've done up to this point is just writing a function. So in this case, I'm going to read my function. And make sure at this bottom you're reading the reference plane, not the actual level line. Then I'm going to add a parameter to this one, and I'm going to call it an instance and a reporting parameter. And this one's going to be, and it's going to say report in parentheses for me, so I don't need to write report. Overall width. And then this one's going to be overall height. Instance reporting parameter. And it's always good to read. Can be used to extract values from geometric conditions. Blah, 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 blah. So it's reading it. It even tells you reading. Well, it doesn't really say reading. Okay, and then I'll do overall height. And then the last part is, and we cross our fingers always, because you know, you really start ducking through the weeds on this. You really got to pay attention to what's going on with your system. So I'm going to say that my system now, and I'm going to edit that type. Its overall height is equal to whatever my grid cells become and determine it to be. And then I'm going to have to be careful because I have two test conditions. So that might break my family as well. So it's always good to go back and delete out your types. But maybe we get lucky today. So I'm looking for overall height. Apply. Woohoo! Sweet. And then overall width. Come on. Louver width. Overall width. Come on, baby. Come on, baby. Yeah. There we go. Sweet. File, save that as family, and God hope that when it gets into the project it works. Curtain, panel, louver, awesomeness. Probably spelled that wrong. Load that into the project. Project 1. Yeah, baby. All right. 3D. Oh, bummer. So that got loaded in. Oh, that's family 1. That's why. So on top of my system, because I renamed it, it became a new family. I'm going to edit the type of this curtain wall. And we're going to make that curtain panel condition be... Curtain panel awesomeness. Top. Don't break. Don't break. Don't break. It's thinking. Uh-oh. Awesome. Cool. So then if I change... So if I take my panel now, and let's say I'm going to delete out some grid lines. So I'm going to take my lines, start removing segments. My grid cells for each one of these should stay... at least my louver array should stay somewhat visually apparent and right, but then it makes my panel bigger. Cool? So treat if you have a double skin facade, right? 2 curtain panels loaded into each other with an offset, right? Or generic model families that are mimicking that idea. So really, if you can build this thing, I'm pretty confident you can build anything in Revit if you can build this system. So. Next week, we're going to take this super cool idea, and I'd like to give you a heads up now since I have this one done. And I'm going to go ahead and I'm going to insert load family. I'm gonna remember where I placed it. Courses 434 BIM. Space frame tool. So I'm going to load in my RFA. So we're going to take next week when we talk about structure, we're going to build this super awesome space frame tool, as well as talk about basics of structure as well. So how this works is if I go into plan, right, we're going to learn about a line-based family, creating a line-based family. So I'm going to go into generic models, space frame tool. This is next week, so it's just a heads up. Basically, we're going to take the same louver logic and parametric array system and build the super awesomeness of double parametric arrays. And we're going to make awesome systems like this immediately. Okay? Fun with Revit. That's it for today. Thank you. So I'll be around as always to answer your questions. Hopefully today I didn't scare anybody. It's too late to drop the course. This is when it starts to get really, really complicated. But it's super easy once you get it, and that's why I'm here. Okay? So if you have questions, I'll be around. Thank you. Come again.